Hi everybody, I'm meteorologist Gavin Sandell. Well, it broke national news yesterday that an earthquake hit the Russian Kamchatka Peninsula yesterday evening. It was a magnitude 8.8 earthquake, but it wasn't the earthquake that made news, but the tsunami that broke afterwards. So I'm going to talk to you guys about both of those and how they form. Let's first talk about the location that it happened. This is off the Russian far eastern portion of the country, and it is north of Japan. It's relatively a little inhabited region. Just this entire Kamchatkan Peninsula right here is about 200,000 people. So there isn't a lot of people that are there, but the earthquake was 8.8 in magnitude, and it struck about 50 miles off of the coast. So the biggest thing there was the tsunami that occurred afterward. But I want to talk about the earthquake. First of all, talk about the locations that the tsunami impacted as well, the entire western coast of the United States and points southward as well. So let's talk about how it forms. Earthquakes are formed by changes in the fault line and how it impacts the regions that are beside it, because we on Earth are on what's called the crust, and the crust is not one continuous area that we're on. There's different plates on a crust, and so we here in Ohio are on the North American plate. If you're in Hawaii, you're on the Pacific plate. So these plates move around all independently, and these differences in movements and how the rocks interact underneath can cause earthquakes. So when you have two plates that are just digging at each other, it can cause them to rub together. And once that pressure gets loose, then it causes an earthquake. And when that earthquake happens, then it sends lots of energy and water. As the result, if it goes underwater, it can send that up to the surface. So once you have water going, it goes in both directions, and when you go towards land, then it causes a tsunami, a very, very large wave caused by that energy propagating from the underside of the water all the way up into the surface. So that's the basis of how a tsunami forms and earthquakes form. Let's talk about how big this earthquake really was by talking about the Richter scale. This is the magnitudes of what earthquakes are. And compared to a linear scale where, let's say you have a magnitude of 4, that's not twice the size of 2. A 4 is 10 times the size of 3. A 5 is 10 times the size of 4. So when you're comparing a magnitude of 2 to a magnitude of 8, the earthquake is 1 million times the magnitude and just the size of a magnitude of 2. So in this case, yesterday's earthquake was an 8.8 magnitude. It was the highest since 2011, and it's the highest on the list here. And this is, we're tied for 6th place here in our records. These are some really notable earthquakes that come before it. The one in 2011 devastated Japan. There was a tsunami that came with it as well. Look at 2004. This caused another tsunami off of the South Asian coast after Christmas Day there. It killed hundreds of thousands of people there. So talking about what happened with the tsunami as well, in the Kamchatkan Peninsula there, up to 30 feet. Luckily, though, the topography just allows there to not really be that much of an impact there. But once the wave went off, 1 to 3 feet were reported in Japan. Up to 5-foot waves were reported in Hawaii. Once you get into the Alaskan islands, the Aleutian Islands, they're located off the coast up towards my hand right there, about 1.5 to 2 feet. Then once you got to the U.S. coast, those waves got to the coast about this morning, our time, really late last evening, their time. They saw about 1 to 3 inches. Portions south as well towards the South Pacific still haven't received the waves. Chile, another earthquake-prone area, still is waiting for their waves to come later this afternoon. So this is something that we're really going to time out once we get into the next couple of days, and really is a historic earthquake. Luckily, though, only one person confirmed dead at this point. With that, I'm meteorologist Gavin Sandell.